You're still watching This Morning on ITV. Start now for our first talking point. We'll be looking at the aviation. Of course, we'll be discussing an assessment of the grounding of Boeing 737 MAX 8 aircraft. Remember that on this program, number one aviation freak man by virtue of ICAO conference of 2017 was made an aviation expert, and by the standard of FAN is aviation researcher and publisher. Of course, he's also a licensed estate surveyor and valuer. Mr. Godwin Ike, very good morning to you.
Hi, good morning, Jeff.
How are you doing?
Oh, wonderful. And how was your weekend?
Yeah, beautiful. We've been doing this most time via online.
Courtesy of
COVID-19. Okay, that's his profile on the screen. Of course, you can reach him in any of those. The phone numbers are there. Email, of course, there. The website, you can check out his YouTube channel where he has most of his programs. And of course, you can equally reach him via Twitter. They're all there. Go close. Just take all of that down. You can snap that with your phone. Okay, now quickly. Some time ago, when we had that crash of Boeing 737 MAX 8 aircraft, you said quite a lot. We just want you to confirm all that you have said to, of course, with the final report that came out from AIB.
Oh, well, this time around, the NTDC of the United States of America and then the FAA, Federal Aviation Administration of the U.S. It's important to refresh the memory of, or rather memories of our teaming, viewers, to remember that 346 souls were slaughtered by two different crashes of, these Boeing 737 MAX 8 due to the failure of one happened in Indonesia and the second one happened in Ethiopia. And so the two accidents put together, 346 souls were lost. And investigation showed that those accidents were as a result of the failure of a system known as MCAS. That's the maneuvering characteristics augmentation systems. Installed.
MCAS.
Sorry?
MCAS.
MCAS, yes. M for maneuvering, C for characteristics, A for augmentation, and S for systems. Maneuvering characteristics augmentation systems, MCAS. Now I'm going to explain it to you very quickly so that our viewers will understand how the world came about this. The best way to start is to trace the history of the rat race between Boeing of United States of America and Airbus of France. These are the two giant plane manufacturers. Call them the best in the world, the largest in the world. There are other manufacturers, both in China and in different other developed parts of the world. Well, these two companies, Boeing and Airbus, they engage in very unhealthy
competition,
rat race. It turned out that Boeing made its workhorse, the Boeing 737. We still have them here in Nigeria, as a matter of fact. They never say die airplane. Best safety record. Giving service right around the world, sold like biscuits. If you know what I mean. it was huge sale and huge numbers around the world, working tirelessly. I mean, I'm talking about Boeing 737, working, not the MAX, but working tirelessly, and everybody trusted and still trusts the Boeing 737. Now, on the other side, Airbus had this similar, size airplane known as Airbus A320. That also was, doing pretty well.
Similar to Boeing 737.
Similar to Boeing 737. Single aisle, medium range, short and medium range, airplanes, single aisle, meant for quick hopping around within a country or even doing international. It was both short and medium. It was good for them. And so people, airliners were picking them up as you would pick biscuits in the shops. And those two planes were doing pretty well. But something happened. Along the line, they realized that the engines that those two old versions were using were not as efficient as they needed them to be. They were consuming fuel about 15% more, and the power, the thrust, those engines, and those were the engines known as pure power. That's the brand of the engines made by Pratt & Whitney. So they call them PW. PW, I think, is 1100, something like that. I think that's the model number of those engines. Then Airbus, thinking it through to beat Boeing in the game of sales and profit, approached a company known as CFM International, who designed and made this awesome, massive engine known as LEAP engine. And LEAP simply means leading edge aviation propulsion. That is L for leading, E for edge, A for aviation, and P for propulsion. And so in a short form of the acronym, they call them LEAP engines, okay? Meaning leaping edge aviation propulsion engines. Now, those engines were...
What year was that?
That was sometime in 2014. Those engines were awesome. Number one was that they saved 15% of fuel consumption from the old
Boeing
PW, still being used by Boeing. So Airbus quickly changed their model of Airbus A320. As a matter of fact, they changed the name of the normal A320 that was using the PW, those Pratt & Whitney engines, to Airbus CEO, and then created one that would use those LEAP engines and named it Airbus NEO. And CEO simply meant current engine option. So they changed the normal A320 to now A320 CEO, meaning current engine option. That is to say, an option for the old PW engine. And then created a new one that they called new engine option, NEO, N-E-O, meaning new engine option. So those ones were the ones that would use the new LEAP engines. Now, the advantage of LEAP engine remains that it would save you 15% of fuel consumption for the same distance that this other one. The power was awesome. It's making the aircraft fly,
that the speed is more than the previous.
Yes, faster. And so with that, lower consumption of fuel and faster, it increased the range of the aircraft.
That means for airlines that are into commercial flight can rake in more money.
That's correct, because it's all about money, business. So the commercial airlines started trooping to Airbus to pick up the Airbus A320neo. That is the new engine option. All right, and so sales were really going on, and of course Boeing became really jealous and said, "Oh, these guys are overtaking us in sales
in this
volume,
business,
in sales volume." So Boeing decided to acquire those CFM International LEAP engines for their own 737, and then rebranded it into what is known as 737 MAX. They actually have them in MAX 7, MAX 8, MAX 9, and MAX 10, depending on the length and size of the of the airplanes. But the one that was cute and suited the competition going on between Airbus and Boeing was the MAX 8. Okay, right now. Here is the challenge that Boeing soon realized that it had.
So the MAX 7, 9,
8, 9, 10.
They were doing well, except the MAX 8.
Well, it wasn't really a point of doing well as in that. It's just that more of MAX 8. Orders were placed more for MAX 8 because it came in between, and it was the size that airliners found quite profitable, to use. So it was the most popular of all the other brands. Okay, but there was a problem, and I'm going to describe it so that our viewers will. I'm glad. Keep us with this kind of view you have, where our viewers are taking a look at. This is a MAX aircraft, actually. You can see. If you zoom in here, you see the 737, and then you see the way the engine is mounted. You would appreciate that it's a MAX aircraft you have in this miniature. Look at what the problem was, Joe. For the Boeing, their 737 naturally hugs the ground, sitting low, like as this one is sitting now. So you're looking at it. That was how the natural 737, sat low on the ground. But naturally, the Airbus A320 was higher, like that, while sitting on ground. So it became possible for the big LEAP engine to tuck in naturally, in the natural way, under the wings of A320 neo. So there was no issue. The neo flew and behaved the way it was designed to behave. But Airbus, Boeing, due to its sitting low in its natural state on ground, couldn't take in those LEAP engines because they are quite massive, with huge bypass ratio. I will explain that later on. The meaning of bypass ratio. So Boeing had that challenge, and then they had the option of either rebuilding the 737 to raise it up and have those engines tucked away, nicely, the way it would behave well, for $13 billion. So it's all money game at the end of the day. And the CEO then of Boeing had these software engineers approach him, and they said to him, "Listen, we can save you $10 billion. With $3 billion, we will do you a software known as MCAS, the Maneuvering Characteristics Augmentation System, which will kick in each time." Because the problem was that having realized that they couldn't tuck in the engine under the wing in a normal way. They had to attach it on top, and it protruded a little bit further than the normal way, just exactly the way you are. Take a look at this engine here. Just exactly the way this is attached. This one you're looking at. If you can zoom it in, our viewers will see what I mean by very well. But dear viewers, take a look, and you see how this engine is attached in this. Yeah, you can see that, right? Normally, it should be right underneath the wing with just a little bit of this popping out in the normal way. Now, the consequence of this Boeing form of mounting was that each time you put power, because of that positioning of those engines, it will give this airplane a high pitch moment. It's a force. So each time you put power, what you find is
and the high pitch is abnormal.
It's abnormal because it creates what is known as high angle of attack. And the consequence of a high angle of attack is that it displaces the air that should be flowing, over the wing, and causes this airplane to slow down, so that the airspeed will slow down. And every airplane design has a minimum speed that keeps it in the air. If it falls below that minimum speed, this plane stalls, stops flying, and then begins to drop off the sky vertically. And once that vertical fall begins, there's no end. No matter how much power, you put.
Like you have always said here, except there's height advantage.
Except there's height advantage, in which case the pilot pushes forward on his joystick, takes a dive, gains speed, pull up, level off, and then recover from the stall, and then you can continue to fly once again. And then that also depends on how heavy the plane is at the time you run into that kind of trouble. If you are heavily loaded with full passenger load and full luggage load, you'll still be doomed, because you may take a dive but don't gain quite enough speed to give you air pressure that can recover you from that dive. Then you'll be pulling, but the plane will just ignore you and continue to dive until it hits the terrain and crashes. That's the danger of those guys. So it's better not to even stall and not to start falling off the skies and start, struggling to recover.
When that was discovered, what was done?
Yeah, Boeing had a chance and an opportunity to quickly rebuild the 737 to raise it off the ground, and then have the opportunity of tucking in the LEAP engines properly, in their right position for $13 billion. But the software gurus said to them, listen, we can do something that will correct the pitching moment, which was the MCAS. And then the job of the MCAS was that each time the plane got into a high angle of attack because of the pitching moment caused by these engines tucked on top of the wings, MCAS would kick in and move what they call it now, elevator. The elevator, it will automatically, without the knowledge of the pilot, without the pilot doing anything, the MCAS will automatically kick in and move this elevator into what is known as a positive position, which this is down is a positive position, which if the wind hits it, it tips up the tail and points down the nose. So that was what MCAS was designed to do. This plane will be flying, and if for any reason the pitching moment of those engines move it up, the sensors, one of which is dedicated to noticing that the plane was sliding into a stall situation, because the pilot may not know Even when you change your, except if you take a look at your instruments, then you see that you are not flying level. But MCAS will notice it, kick in, and then bring down this nose
to normal
to a normal position. But MCAS was
and that
not,
sounds good.
It sounded good to the CEO. $10 billion was not a mean joke, and all the commissions and whatever benefits that will come from those kind of savings. The CEO then, you know, he's not there anymore. He's been shown the way out. Chose the option of
the MCAS.
The MCAS. So here is another thing that happened. FAA, the Federal Aviation Administration of the United States of America, whose business it was to monitor and ensure that what was being designed, what was being put out for the world to use was safe enough, because of the awesomeness of Boeing, and it was the cash cow of United States of America as a government and as a country, and so really respected by everyone. FAA ceded the certification of what they were doing to the designers and manufacturers. It's just like having our NCAA here and some private manufacturer known as GODDY, Aviation Manufacturing of Nigeria, and then rather than NCAA coming around to check that we are doing what is appropriate and what's safe and others, they say, oh, come on, these guys are just damn too big. They
can't make mistakes.
They can't make mistakes. We trust them. And then they allow us to assess ourselves, allow the GODDY and partners to assess itself and tell the world that it's okay. And then NCAA will simply put its stamp and adopt and say, oh, well, it's okay. That was what happened between FAA and Boeing. So a whole lot of...
Okay, now to the crux of the issue,
yes.
We're really running out of time.
Yes.
You did predicted that, or suggested, or recommended that MAX Air, Boeing 737 MAX 8 would never fly again.
Oh, yes.
Yeah, and when that report, you are not an authority, but on your own
assessment, yes.
Being a freak and an expert, a researcher, a publisher.
Yes.
Your recommendation was that with what has happened, this will not fly again.
Yes.
And when the authorities saddled with the responsibility to investigate and give report of what has happened, it coincided with your recommendation.
That's correct. And I am going to quickly, in 2 minutes, reel out what I said to the world, at that time, when I said my verdict on the future safety of Boeing 737 MAX aircraft. Let me quickly read it graphically and refresh the memories of our viewers. I said, having graphically highlighted everything the world needs to know about Boeing 737 MAX aircraft in the past 4 weeks, because we did them in 4 episodes, about MAX. We had part 1, part 2, part 3, and part 4. And I said, in the past 4 weeks, I most humbly deliver my verdict on the present and future safety of Boeing 737 MAX aircraft based on its current configuration. And I said, Boeing 737 MAX aircraft is a product of an unhealthy competition between Boeing of USA and Airbus of France. MCAS relies on a single point of failure system for its operations. Only one out of the 2 exterior sensors supplies it the data it uses to kick in. So it's a single point of failure. That means if it fails, everything fails. Okay. Now, airspeed. That's my findings and what I published. I said airspeed, altitude, and angle of attack are not absolute parameters. No one should therefore rely on them for an automatic augmentation system such as MCAS. But those were what MCAS relied upon to make its decision to kick in or kick out. But so I am saying they were not absolute and therefore should not be relied upon. Then I said, from every indication, MCAS cannot guarantee safety in the Boeing 737 MAX aircraft. The parameters it relies on are not stable and trustworthy. And then I went on. I'll give you the other bit of it that I went on to say very quickly. MCAS can never solve the upward pitching moment generated by the LEAP engines installed in the manner they are in the Boeing 737 MAX aircraft. No amount of upgrade of the software will do the magic. You remember when the first crash took place and it was being suspected, the engineers, the electronic engineers went in and said, oh, we've done an upgrade of MCAS, that this one is awesome. It wouldn't, yet,
another one happened in Indonesia.
No, this time around in Ethiopia. You know, fell off the skies and slaughtered even more people, adding up to about 346 souls. Then I said, I would humbly urge Boeing to consider rebuilding the 737 MAX in a manner that the LEAP engines can be installed in the old traditional fashion that will make MCAS totally unnecessary. And I went on to say, I understand the cost of such rebuilding might go beyond $10 billion, as against slightly above $3 billion for the MCAS cost as a solution to the upward pitching moment. I understand that, but how much can anyone really pay for 346 souls if $10 billion is what the issue is? Then finally, my urge Nigeria, and indeed all the countries of the world, never to accept a Boeing 737 MAX that uses MCAS ever flying over their skies until Boeing does the needful by rebuilding the 737 MAX in a way that renders...
How did you arrive at this recommendation?
Very well. Deep study. I went in graphically. I picked up MCAS and everything, the thinking that all the engineers put together to design the MCAS. I went in and researched very deeply, and I was following the running of their heads, their brains, their minds, what they were thinking as they were putting things in place. And then I found out from my own little knowledge of science that some of the parameters they were relying upon to say that, listen, this will work, that those parameters were not absolute and could not be. It's just for, like Joe, people say that the weather is treacherous and can't be trusted, because you may step out one moment and you see the sun shining, and suddenly the cloud comes in, the sun disappears, rain is already falling on you. That's why it happens more even in Europe and America than it happens in Africa. That's why they say that somebody is as treacherous as the weather. That means an individual you cannot trust,
cannot predict,
and you cannot predict. So I found out that the parameters that they relied upon were untrustworthy parameters. And then I just wondered and imagined, for instance, if you're relying on wind speed to say, okay, Mr. MCAS, if you notice that wind speed has gone this way, and you notice that the density of air is so much, then kick in and do this and do that. Those were the the designs that they put in the software. Then my question is, what if you were flying through air that had thick density, and the MCAS was relying on the density of the air at the time and the speed, and suddenly you leave a zone of high density into a zone of low density suddenly, and then the air movement that used to be a tailwind for you suddenly becomes a headwind, or comes by your side in form of a shear wind. How would that machine that is not human, that is garbage in, garbage out, how would it change his brain quickly to know that, hey, this is not what I'm used to? For a human being, that's why we are humans. If you are given instruction, even by your boss, and then you go out there and see that the reason your boss gave you that instruction has changed, It's either you pick up your phone and say, boss, this thing you're asking me to do won't work because here is the new situation I'm finding here. And the boss will say, okay, do what is needful. And then use your initiative and do it. But not a machine that is been programmed. Garbage in, garbage out. If it changes, the machine won't change. It will rather do nonsense.
Unless it is imputed that when it's changed, you can also act accordingly.
It's always garbage in, garbage out. So that was the problem with MCAS. And what was more, one other silly thing that went on that Boeing did was that they were so sure of this software that they they didn't even bother to put it in the manual of the airplane. They didn't even bother to give pilots training. For instance, the normal autopilot will be running and your joystick for those semicircular ones will be moving. If for any reason you don't trust what the autopilot is doing anymore, you grab your joystick and resist the autopilot, it kicks off immediately. That was the old system. But for the MCAS, the thing was hidden, in the trimming knob, and nobody told pilots at the time that in case you had problem and you wanted to take back,
you can reach it. You can reach it somewhere.
You can reach it at the trimming knob. So pilots didn't have the information. It wasn't in the manual. They weren't trained and they weren't informed about it. So for those two crashes, the pilots noticed that the plane was misbehaving. It will go up, it will go down, it will, shake, and then they were struggling with their joystick.
We must thank you so much, Mr. Gordon Ike, for this very deep assessment and analysis of Max Air. When you came out with that verdict, we were like, what is he talking about? But at the end of the day, when we have that report from the authority, it's as if you have already given them an expo. We must thank you for coming on the show this morning. Because the much we have with Mr. Gordon Ike on the aviation. Of course, he is a licensed estate surveyor and valuer and just big interest in aviation. Most time they call him a non-pilot that is his pilot. Okay, many thanks for coming on the show.
My pleasure.
Yeah. So we take a quick break. When we come back, we are going to Edo State to look at how it happened, the process and outcome. Stay with us.